So this is just a continuation of 3.4 graphing polynomials, trying to keep the videos a manageable length. So we just stopped after the first example and starting again with number 2. So we want to start doing the same things we did the first time, going through these steps when we're graphing, finding the zeros, finding the y-intercepts, the mid-intervals, the end behavior, and then graphing the polynomial. There's 4 different shapes that it could be. So with number 2, start by using some synthetic division to find the other zeros, because we know one of them is 2. So hit pause, see how far you can get on those steps before you come back and check. All right, so we have 2, -1, 2, 4, and -8 across the top. When we solve that all out using synthetic division, we end up with a 0 here, which we knew we would get because it said it was a 0. And then we go ahead and put that into a quadratic. These are the coefficients of a quadratic. And then we're going to solve the quadratic. Now, we don't like factoring when we have a negative leading coefficient. So we want to factor that out. So we have x squared minus 4 now. And x squared minus 4 is x minus 2, x plus 2. So that tells us that we have zeros of x equals 2 and x equals -2. So when we list our x-intercepts, like we did before, we have a 2 here and a 2 that they gave us. So we have 2, 0, then we also have -2, 0. The fact that this one shows up twice, we call that a multiplicity of 2. That 2, 0 right there, multiplicity of 2. And that means that it is going to bounce off of that point. So when we get to the graphing stage, our graph is going to bounce off of 2. Anytime it has a multiplicity that's even, it bounces off. All right, y-intercept. So y-intercept is when we put the 0 in for x. Remember, if we put a 0 in for all of these x's, then those all go away and we're left with -8. And then we want to find our mid-interval. Our mid-interval is when we average our x-intercepts. So if we average these, 2 plus -2 is 0. So it turns out that our mid-interval is the same thing as our y-intercept. And then we need to talk about our end behavior. So we need to know what the basic shape of this graph is going to be. Well, if we take a look, we have an odd degree and a negative leading coefficient. Odd negative means we're going to start high and go low. So now we have to write our 2 statements. As x approaches infinity, f of x approaches, well, infinity means we're moving to the right. So where is our function going? It's going down. So it's going to go to -infinity. As x approaches -infinity, f of x approaches. -infinity means moving to the left. And as we move to the left, ours goes up. So it's going towards +infinity. We're going to put all that information together on the graph. So we have a 0 at 2, 0, a 0 at -2, 0, a y-intercept at 0, -8, and we know that it has to start high and go low. So it's going to start up here, go through, get to the 2, and remember when it gets to 2, we said it was going to bounce off, so it's going to hit that one, bounce off, and go back the other way. So notice how your graph resembles the sketch that we made here. Left side going up, right side going down, bouncing off that 0 because it showed up twice. All right, last one. We're going to do the same thing again. Go through all of those steps on number 3. So I would like for you to pause it, see how far you can get. We're still going to be doing synthetic division. But notice that the directions say that 1 is a repeated 0. So that just means when you do your synthetic division that you're going to use 1 twice. Okay, so use 1 and then you'll use 1 again. So go ahead and pause it, try it, do your synthetic division twice, and then come back and check to see if you got it right. All right, so I've already done the synthetic division once, but now I'm going to do it again a second time because it said that 1 was a repeated 0. So it's going to show up more than once. I guess it doesn't even say how many times it's repeated, so maybe it's going to be repeated more than once. We'll have to find out. I mean, more than twice. So once we do it again, we get to the quadratic part. So we're going to make a quadratic out of what we have there. And then we'll have to factor something that multiplies to get -2 and adds to get 1. X plus 2 and x minus 1. Now we can list our x's. We can have a -2 and a +1. And looky there, 1 showed up a third time. So when we state our x-intercepts, we're going to have -2, 0, but we're also going to have a 1, 0. It showed up 3 times, so that's a multiplicity of 3. When it has an odd multiplicity, it cuts through. So it doesn't bounce like on the last one, it just cuts through the line. All right, then our y-intercept, much easier to find. Just put 0 in for all of those x's, and we end up with our constant of -2. The mid-interval is when we have to find the average of -2 and 1. That would be -1/2. Put it back into your function. And we find out that the y value is -5.1. And then the last thing before we graph is the end behavior. So we look back at the original, let's see, equation was an x to the 4th. So we have an even positive. When it's even and positive, it's going to look like a parabola where both ends are up. So as x moves to the right or towards positive infinity, looks like our end is also going towards positive infinity. And then as x moves to the left towards negative infinity, our graph is also still going up towards positive infinity. See how both of them are heading up towards positive infinity? So they match. They're both towards positive infinity. All right, let's put this information on a graph. We have -2, 0 and 1, 0. And then -1/2, -1, 2, 3, 4, 5.1. Oh, and I forgot the y-intercept, 0, -2. So we know it starts up here, goes through this mid-interval, but then kind of has a weird curve before it heads up again. So not a perfectly looking parabola, but the ends look like the parabola. So they are both heading up, and it just has some weird curves in the middle. And that's all for 3.4.